Next, we'll be going over network topologies. A topology is usually a schematic description of the arrangement of a network, including its nodes and connecting lines. So the topologies show us how we are connected, how our systems and devices are connected with each other. Network topologies define the layout of the virtual structure of a network, not only physically, but also logically. The way in which different systems and nodes are connected and communicate with each other is determined by a topology of the network. Like we are in a ring topology or tree topology, we'll discuss these in a bit. So topology will explain how devices are connected to a network. First, you have to understand what typology you're using. Maybe it's a ring topology, maybe it's a tree topology, maybe it's a star, or maybe it's a bus. So let's discuss these different topologies, like bus topology, star, ring, mesh, tree, and hybrid. First, we'll review the bus topology. A bus topology is a network type in which every computer and network device is connected to a single cable. When it has exactly two endpoints, then it's called the linear bus topology. Here you can see how it works. All the devices are connected with a single line. So in bus topology, when devices are connected in a single line with a single cable, you can say so that is called a bus topology. In the bus network topology, every workstation is connected to a main cable called the bus. Therefore, in fact, each workstation is directly connected to every other workstation in the network. Each topology has its own set of pros and cons. In the case of the bus topology, if A wants to communicate with C, in order to achieve this, A has to transfer the data to B, and then B will transfer the data to C. In a bus topology, all devices will communicate in this way. If you have 500 systems running on a bus, then in order to communicate between the two ends of the system, you'd have to transfer the data through all 500 stations. So it is a time-consuming process and has certain vulnerabilities. For example, if A is transferring to C and B goes down, the transfer cannot be completed. The next topology we'll review is the star topology. In the star network topology, there is a central computer or a server to which all the workstations are directly connected. Every workstation is indirectly connected to every other through the central computer. In this type of topology, all the computers are connected to a single hub through a cable. This hub is a central node in which all other nodes are connected. Here, all the devices are connected with a single server or network device that is the hub. System A, B, C, and D are connected with a single hub in case System A wants to communicate with System C or any other system connected to that hub. Communication between nodes goes through the central hub, making communication more flexible between stations. If System 1 needs to communicate to System 500, then System 1 only has to transfer to a single hub, and then that hub will redirect the information to System 500. It will not need to communicate with all the devices between. Directly, System 1 can send a request to the hub, and the hub will forward the request to System 500. Next is the ring topology. It is called ring topology because it forms a ring as each computer is connected to each adjacent computer with the last one connected to the first. Exactly two neighbors for each device. In the ring network topology, the workstations make a closed loop configuration, with adjacent pairs of workstations being directly connected. Other pairs of workstations are indirectly connected, meaning the data passes through one or more intermediate nodes. If System A wants to communicate with System D, then System A will forward the request to System B, then to System C, and then to System D. A ring topology always chooses the shortest possible path between systems. So with System A and System D adjacent to one another at the beginning and end of the ring configuration, the data can transfer between these two systems without any intermediate nodes. Next is the mesh topology. Mesh topology is a point-to-point connection to other nodes or devices. System A is connected to System B, C, and D at the same time, so all systems are connected with each other point-to-point. The mesh network topology employs either of two schemes. The first is called a full mesh, and the second is called a partial mesh. In the full mesh topology, each workstation is connected directly to each other. And in a partial mesh topology, we can create a mesh according to our own specific requirements. For example, if there is no need for System B to be connected to System D, then we can disconnect that line. This will create a partial mesh, according to our requirements. But in this example, all the systems are in full mesh topology. The next one we'll go over is the tree topology. Here, all the systems are connected like a structure of a tree. The tree topology is made up of a root node and at least 2 other star topology configurations. This makes the tree topology a hierarchical system. It should at least have 3 levels to the hierarchy. The tree network topology uses 2 or more star networks connected together through the root node. So a tree topology uses 2 or more star networks, and as you can see in this architecture, the central computer of the star networks are connected to the main bus. Thus, a tree network is a grouping of star networks connected to a main bus or a root node. System 1 is the root node in the example above. Hybrid topologies is just a mixture of 2 or more topologies. A network in which we are using a bus and a star topology is a hybrid topology. So unlike other network fault detection and troubleshooting, it is easier in this type of topology because there are different parts to communicate. So we can easily find where the fault line is. It's easy to increase the size of networks by adding new components without disturbing existing architectures. For example, if we want to join a star network to a bus network, we are building a hybrid system.